So I want to talk about tolerance. And you have two types. You have stenohaline, which are basically non-tolerant. These are animals that can only survive over a narrow range of salinities. And then you have euryhaline, and this is a large range of salinity. So these guys are very tolerant to different conditions, and these guys are not tolerant. Okay? So when we think about these, if I were to look at a range of salinities from sort of fresh water to the ocean, what you'd find is that your euryhaline guys might be able to handle a pretty large swath. And within that swath, they're happy, and outside of that, they're dead. Okay? Where your stenohaline critters can only handle a very narrow range of conditions. So they're only good for a small part of the environment. It could be here, could be here, it doesn't matter. You'll just notice that they're only tolerant over a small range of conditions. They can't handle, in this case, a somewhat salty environment. Okay? So, we love to talk about this when we talk about conformers and regulators. Now, I'm going to do the graph. If we look at the environmental osmolarity from, this would be like salt water over here, and over here would be fresh water. And we look at the animal's blood osmolarity. What you would find, similar to what we saw before, what you'd find is what we found before. A stenohaline animal is only going to be tolerant over a narrow range of conditions. A euryhaline animal is tolerant over a broader range of conditions. But I want you to notice something here. Notice in these lines that I just drew, this blood osmolarity is constant. Even when the environment changes. What that means is that these guys are regulators. We can draw what conformers look like, and what conformers would look like in this case, and I'm going to use a slightly different color, although I guess I'll try to use the same shade. A conformer's blood osmolarity will increase as the osmolarity of the environment increases, because it's going to be matching the environment, it's conforming. So this is a conformer. So this conformer is happy over a large range, so this would be a euryhaline conformer. We can also have a conformer that's only happy over a narrow range. So it conforms, its blood osmolarity changes with that of the environment, but it only has a narrow range of tolerances where it can stay alive. And this would be a stenohaline. So the things to look for are if the blood osmolarity increases as the, so here the blood osmolarity is high, and that happens when the environmental osmolarity is also high. That suggests that we've got a conformer. Here, despite what is going on in the environment, the blood osmolarity remains constant. It's a flat line. That tells you that they are a regulator. And then the length of that line tells you whether or not they're euryhaline or stenohaline. The same exact thing happens with eurytherms and stenotherms, only with those, we're not going to be talking about blood osmolarity. We're going to be talking about, we'll be talking about body temperature. And the environmental temperature from cold to hot. And you'll see the same thing for stenotherms and eurytherms. The eurytherms are comfortable over a large range. The stenotherms are comfortable over a very narrow range. So not very tolerant. All right, hopefully this has helped you to understand sort of the Steno and Eury thing. And if not, ask me about it tomorrow.